So I'm going to share my screen now. Yeah. Okay, tell me if you can see my screen.
It's loading right now.
Okay.
So yeah, I can see it now.
Okay, nice, nice. Good. Okay, that's fine. Okay. All right. Okay. All right. So you know this app I'm using, right?
I don't know what app is that.
My Paint. It
Sorry?
I know it's Microsoft
Oh yeah, Macros. Oh yeah, I do.
P. Yes, yes. So you may know it. Most people have other apps that they use for like literally writing, that would enable them to write easily. But I don't really have that like a light pen, screen pen, but I use the mouse, the the mouse pad and all that. So it's
Okay.
still an experience that I want. Okay. So where I
Okay.
need type, simply type, yeah, geometric sequences. All right, all right. So, right. So the first thing to see is term sequence. I'm sure you already have a fair idea of what sequence means, right?
Yes.
Okay. So if someone asks you, what would you tell the person?
Sorry?
If someone asks, like the person says, okay, goodness, what's a sequence? What would you tell the person?
Uh, how I understand sequence is like the differences between number, how number goes each time.
Okay, okay. How numbers go. Okay,
Each
so
time. How
each time, okay. Go ahead.
how they add to each other and how the same number add to a number.
Okay, okay, okay. So let's see if I understand what you said. You already on that a sequence is that's several numbers in a particular order, isn't it?
Yes.
However, how one number leads to the next one may differ from sequence to the other.
Yeah.
Did I that what you said correctly?
Yes.
Okay, good. So it can be addition, and I think addition the primary way you have sequences in arithmetic sequence. That's the simplest one that we know, addition. Um,
Yeah.
and then in the case of a geometric sequence, that would be a multiplication, isn't
Uh, so what we are doing right now
it?
is we I don't know if I can share my screen to show you the
Okay,
page.
all right, all right. Okay, please go
Okay.
ahead. Go ahead.
So I want to so
Okay,
and then we have a formula
okay.
to solve um how to solve the formula for solving it.
Yes, yes, exactly. Exactly. Yeah, so that's an example of a geometric sequence. Exactly. So that's what I was saying. The multiplication is how we would, be able to tell the next one. So if you look at first sequence, you have the 3, 6, 12, right?
Yes.
The very first.
Oh,
Okay. So So, what in that case, you'd that you are simply multiplying by two, isn't it,
oh
to
yeah.
get the next. Exactly.
Yeah.
So, okay. No, don't tilt your phone that way. Just hold it the way you are holding. If I could see everything, you could see it. Okay. So yeah, a sequence in which each term after the first is on multiplying. Exactly. So that's it. Okay. So the general formula, right? The general formula is there's a general formula. So what
Yeah.
you call common ratio for your geometric sequence um um is what is called common difference for arithmetic sequence, right?
Oh, yes.
Yes.
Common
So
difference. Yes.
exactly. Common differences for arithmetic sequence. Now, it's really good to have what is the differences between one sequence and what you expect. So I think this is fairly simple enough. Um, Common ratio is given by any term divided by the previous term. I hope you know you understand. Any
Yeah.
term could mean even if the any term is smaller than the previous term, this formula will still hold. Okay, then when we come to examples like that, I will remind you of what said now. Okay, so let's see. Okay, could you scroll? Let me see if the formula was given to you. AR super n minus
This.
1. Exactly, exactly. That's it. That's okay. So that's the general formula for a geometric sequence. Okay, so beyond that, was there any other thing said, or you just
Yeah.
example?
This was the example.
Okay,
Uh. Yeah. This was what we did.
okay, all right, okay, okay, all right. Okay. I would have okay. So, okay, I'm just wondering, was there any reason you could not join the meeting from your laptop, or is it a regulated laptop?
Yeah. It's a school laptop. It's like
Oh, I
they have. But
see.
I will try to see if I can. Wait.
Install Zoom, right?
Yes.
Okay, okay, okay. All right, it's fine.
Okay.
Okay, it's fine. If you can install it, that's fine. Maybe from next class we can do that. Okay.
Okay.
All right. So let me see. I will let me see. So you know the good thing about now, we'll get to once you get to do more examples. How many examples were you guys able to do in class today?
We did two, but this is the homework.
Okay, okay, all right. Okay. So is it possible? Okay, have you already done it, or this one is
So,
classwork? This one that is looking like this looks like classwork to me.
she just. I think she just solved it there for us to like practice.
Oh, I see. Okay. All right. Okay. Can you say, is it possible that I see this link? If I click on this link, if you send it to me um via email, if I click on it, or it will need me to sign in?
Oh, I
It is. Don't
I
worry. If it will need a sign in, don't bother. Hmm.
I will see if I can like add
Okay.
my personal email to it.
Oh, okay. Okay. All
Yeah.
right. No
I
problem.
will have to set it
Okay.
up first.
Yeah. Yes. Okay. All right. That's not a problem. Okay. Let's see. You can, if it's possible to see question, I'll just go through them again, and I think I'll explain as I go along. Um, but I think the concept is pretty straightforward. So
Mm.
we'll just do each of them. How many of them are there?
Um, Wait, I think the one we did today was
Yeah.
I want to because this
Okay.
we didn't do this part today, so I'm trying to look for the one
Okay.
we did.
Okay. Okay. All right. Go ahead.
Oh yeah, we also did quadratic sequence today.
Okay.
This was the
Okay.
main thing. The geometric was just another topic for another day. The
Mm,
continuation. So this
okay.
was the
So we
main thing we did today.
you the quadratic, right?
Yeah.
Okay. All right. So for that quadratic, what if to do a comparison between them? Um, okay. Let's see if we can get an example of quadratic sequence. Okay. Let me see. Okay. Can you zoom in on this? Let me see what you have there. Okay. Okay. So it's describe the pattern 2, 5, 10, 17. Okay. So I'm taking a look at this. Yeah. 2 plus 3 is 5. 5 plus 5 is 10. 10 plus 7 is 17. Um, okay. Okay. So a quadratic is it's at some point it looks like arithmetic, but it's just that what you would have called its own common differences increase with a fixed value. So that's 3, 5, and 7. 3 plus 2, 5. 5 plus 2, 7. Okay. Hmm. Okay. Now, if I were to just ask you for your own observation, comparing that sequence to geometric sequence, which one would you say you understood easily?
Is he part of this
Do you understand the quadratic sequence is
this
very
this
well?
part?
Yes.
I do, yes.
Okay. Okay. So let's see what's the general if for this particular one, let's see what's the general formula for quadratic sequences.
This
Okay. Mm-hmm. A n raised to power 2 plus b n plus, and that is actually the what do you call it? That's actually the general format for a quadratic equation. So technically, quadratic sequences are formed by um, the same sequences for quadratic equation. Okay, all right. So let me see if I can. I'm trying to see if I can get something. You said you are in what grade again?
um fifth grade, like SS2.
Okay, feel it. Okay, okay, okay. All right. Mm, okay. Okay. All right. Since the let's we can work with this. Okay, so I'm going to share my screen. If there's any part that is very similar with what you already have, right? Just let
Yeah.
me know.
Okay.
And then if there's anything that you don't understand in class, you're seeing it, also let me know.
Okay.
Okay, all right. Thank you for sharing. Let me share mine so that we can just look at the matter I have here. And then if we, okay. Okay, can you see my screen now?
Yes, I can.
Okay, nice. Okay. So there are quite a lot of things. I hope I won't beat it. Uh, that's usually the issue with uh, because my some form of adverts too. Okay, so um, so I think this looks very similar. Um, Quadratic
Yes.
sequences have a second difference. So that's line one, where the difference for between one is three, and then if nine is five.
5.
So increasing by two instead. So uh, uh, the second difference is two. Okay, okay. So let's see how we can if if we find the second difference for this one, right? How would we think
Yeah.
about it? How would you about finding the second difference for this one? So do we have
4.
okay. And then between 12,
5.
that's five. Okay. Between 12 and 20,
6.
that's okay. So of course it looks like the
7.
so I guess the second common difference is one, right? Right?
Yes. 1.
So let's remember including plus one in between. Okay, that's good. So the find is quite uh, easy. Okay, all right. So let me go next slide. Now, did you guys do ones like that involve negative numbers? Did you do anyone that involve negative numbers?
No.
Okay, you can do it involve negative numbers, right?
Yes.
But
Hello.
good, send me.
I can hear you now.
Okay, like my thing, I did like maybe not charge properly, or I need to properly. Uh, okay, all right. Sounds good. Great. Okay, so that just for the sake of this, we really have to make it in this. So can we just give it a try. See what happens when you have a safe number.
Okay.
So you say it's happening between -6 and 5. What would add to -6 to give
11.
11? X 11. So yeah, let's stop that. Okay. And what would be to give us for that would be
35.
35, right? Okay. So and then of course 29, right?
59.
59, yes. Okay. So let's establish here between these ones that we even discussed. So from 11:35, between that is
24.
24, yes. Okay. All right. And then this is also
20,
25, right?
24.
5 minus 2 is 24. So the common second difference is um second common
15.
difference is 24. Yes. Okay. All right. Sorry. Let me get clear before. Okay. All right. Okay. Okay. So this one is usually this one's quite straightforward. All we just need to do is to find what's happening between them. Right. So now I think you can by examining six, you can know which one is arithmetic, which one is quadratic, and which one is geometry. Can you do that?
Okay, I will do it. I'll show you.
Okay. Okay. So take a look at these things that are that are on the um this one, this one, this one. So if you then which one is now, of course, another name for linear is arithmetic. Okay, so let's just get that straight from the start. Another for linear is arithmetic. Another name for exponential is cake. And of course, there's no, I think just use the quadratic. So that one still right what we did. Okay, so which of them do you think is linear or arithmetic in this case?
The first one.
The first one, okay? Let's see if that's correct. So the one, what would you say is common difference?
6.
Um, would say is 6 or -6. Do you understand my question?
Yes, I understand.
Yeah. So I think, don't you think it's minus?
Sir,
I was asking, don't you think it's not sort of just
I can't really hear you very well.
coming now?
I can hear you a bit.
Okay, maybe I should use let me see if I use my okay. Let me connect. Okay, can you hear now?
Yes, sir.
Okay, so I was saying that yeah, you said 6,
but I think it's because it's actually minus six. Remember the common
Oh
difference is
yes.
what you would add to the to any term to get the next term. So it will actually be minus six. It's actually reducing. So yes, the common difference for this is um it's minus six. That's the common difference. So it's an arithmetic sequence. Okay. So what would you say about the next one? What kind of sequence is it?
Mm.
What kind of sequence is the next one? We have two, we have six,
Doesn't
uh,
I'm not sure about that one because it doesn't match up to be a quadratic.
okay, it doesn't match up to be a quadratic. Do you want to check if it's geometric
Yeah,
dimension?
I've done it.
That's okay. So which one did you see any there?
It was wait. It was 4, 12, 36, and then 8, 24, 42.
Okay.
72.
Now, okay, so that means it's not quadratic. Let's check if it's geometric. Remember, geometric is gotten by multiplying something steady, isn't it?
Yes, sir.
Okay, so let's see if it's geometric. How about that? Let's try. Between two
Okay.
and six, how would you get six from two? You would multiply by three, isn't it?
Yes.
Uh-huh. Now let's see if you multiply six by three, what do you get?
18.
18, correct. And if you multiply 18 by three, obviously you will get 54, isn't it?
Yes, sir.
So that means the common ratio in this case is three. So in other words, it is a geometric sequence. So I'm going to denote it there that it's a geometric sequence. And of course, I mean by now you would know that another name for geometric sequence is exponential sequence, right? That's
Yes, sir.
that's this one. Okay. Nice one. Okay, so I'm thinking that this last one has a couple of negatives. But let's take a look at it. So this last one, I'm thinking this last one is quadratic, but let's not fingers crossed. Let's just check it out. So what will we do to minus 12 to get minus 11? What will we add? That will be 1, isn't it?
Yes.
Yes, that's 1. But we're going backwards. So if we add 1, that's plus 1. The next one between minus 11 and minus 7 is plus 4, isn't it?
Yes.
This one looks like quadratic, but then we've not established it. But let's just continue. Between minus 7 and 0, that's going to be plus 7, isn't it?
Yes.
Okay. And then finally, between 0 and 10 is going to give us what? 10
10.
plus. Okay. So let's see. So what's the second common difference? That's going to be 3, isn't it?
3. Yes.
Okay, nice one. So this is obviously a quadratic sequence. So let me just do it there. Q and okay, nice. Okay, do you want to take note of this example?
Yeah, I've
Do you
written
have
it.
a notebook? Okay, excellent. Nice one. Good job. Okay, so let's uh I'm just clear all drawings now. Okay, okay, okay. All right. So you've also taken note of the fact that the other names for arithmetic and geometric sequence, right?
Yes.
Okay, nice. Okay. Um, Okay, let's see. You could this is another one for us to come. Let's see. Okay, so take on the first one. Let's see if you can figure it out. That's 8, 13, 28, 30, and 48. Okay, so goodness. Anything? Have you been able to come up with anything?
It was giving me 515, 515.
515, 515.
Yes,
Hmm.
sir.
Hmm. Okay. Uh, yeah. So this one is not. Uh, it's not now. Now, can you see the among the options, the questions it's saying linear, exponential, quadratic, or linear? So obviously
Mm.
this one is out of their league. It's not even. But it's a sequence, but it's not. It's not the kind of. It's not in any of these three. Okay, so let's look at the next one. 7, 70, 169, 304, 475. I think this second one, 7, 70. If we were to find the difference between 7 and 70, what would that be?
63.
63, right?
Yes.
Okay, okay. So let's see. We just want to establish if it, and then between 70 and 169, that's 9, 16
36.
minus 7 is
Oh, 99.
99. Okay. Then between this one and this one, that's 14 minus 9,
That's
5.
one 135.
Okay, 135, yes. Okay, okay. Um, let's just do this last one. Between this one and this one, that's 171, right?
Yes.
Okay. All right. So let's see. Is there any constant this thing, second common difference? 63
Yes.
plus what will give us
36.
96. Okay. Okay. So if we check, is 36 also what's happening between these two?
Yes.
36. Okay, nice. Because 9 plus 3 is 12. Yeah. Okay, that's good. And then finally this one, right?
36.
36. Nice work. Okay, that's a good one. Excellent. Okay. So that's nice. That's good. Okay, so this particular material only has eight slides, so that's fine. I wanted to just find out something. When you guys were doing arithmetic sequence, did you guys do um what do you call it? The sum of an arithmetic sequence. Did you guys do it?
Yes, we have the formula.
Okay, okay, good. So those formulas, let me ask another question. Do you find them easy to remember?
Uh, the no, I know some, but like not all the time. But I can
Okay,
use it to solve it.
okay, nice, nice.
But
Now,
there are
whenever
some
they give you
questions.
a step, yeah, go ahead.
There are some questions that I can't use it to solve. Like the way they ask the question is kind of confusing.
Okay, okay, okay. All right. Now, yeah, when you say it's kind of confusing, are you talking about arithmetic sequences or
No, not
what are you talking about?
the exam. Yeah, the part of the examples,
Okay,
part
okay.
of the
All right.
example questions.
Okay, all right, no problem. So maybe that's the one we should focus on now. So let me switch back to my Microsoft Teams. So you just give me the if you can, is this something you can read out so that I'll take note of it
Is it
and then we'll
the formula, or should
no
I
the
show
one that
you?
you yeah the one
Oh
that
yeah.
you said you had problems with.
Okay. Mm, Sorry, a second. Oh yeah, this question 14. This one.
Okay.
This was the old explanation for it, but that was the question.
Mm, okay. Okay. Let me see. The nth term of an arithmetic series is I can't really see. Is that Cn equals 52?
Yes. Tn equals to 52 minus 4n.
4n, then 9. Okay, so it now says find the values of um
A
n
and
and is it a or n? Okay,
A
a.
and
Okay,
D.
I've seen it. I've seen it. I've seen it. Okay, a and d, and then it now says for which term is find which term is 0. Okay, okay, I see that. And then the next one it says is find the sum of the terms which are positive. Hmm. Okay. Find the sum of the terms which are positive. Interesting. Okay, let's start. Let's see if we can pick on the first one. Um, it says find the values of A and B. Okay, so let me see. Okay, so let me share my screen. Let me just take note of that. Cn equals 52 minus 4n. Okay, Cn equals 52 minus 4n. I think I took note of that. Okay, all right. So tell me if you can see my screen now.
Yes, I can.
Okay, nice. Okay, so let's just see if we can take on that question. And Cn equals 52 uh, minus n, right?
4n.
N of all right, 4n. Okay. So, uh-huh. All right. So the first question is to find A and Z, right?
Yes.
Okay, good. Okay. So now let's remember that the general formula says that Tn equals A plus N minus 1 and then
D.
Z. Okay. Okay. All right. So once we have this settled, let's now see how they look. We'll compare them. But we can't do any comparison now. Why? Because it's still the first stage. We've not really made any changes. So now you know what we're going to do. Let's work on this guy, this second one, this second equation that we just, the formula that we just wrote. Now remember, all these A, N, and D are numbers. So the same way you would treat numbers, it's the same way we would treat the letters. So now, if I had a number, either on the left hand side of a bracket or on the right hand side of a bracket, what is happening between the bracket and that number? Can you remember?
Multiplication.
Thank you very much. That's multiplication. So what that means is that I can further develop this formula to look like this. That the D would multiply N to become,
EN.
you can say N or ND, anyone, at least
Yeah.
for now. Both of them are numbers, right?
Yeah.
So we are not, yeah, that's the important thing. Um, so, okay. So the next thing that we have is uh, ND minus D, because D times minus 1 is minus D. Okay? All
Yeah.
right, good. So here we go. Now remember, D and A are numbers, right? N is also a number, but it's just that N is more like the position one, and that position one can change from one term to the other. But the ones that don't change are A and D, isn't it?
Yes, sir.
Okay. So once we understand that, let's now rearrange this formula. If I were to arrange this formula in terms of the ones that cannot change versus the ones that can change, guess what is going to happen? I'm going to have and minus z, they will come together. In other words, I just brought the minus z closer to a. Okay. Then I'm left with the plus. Okay, so there we had it plus nd, but I said I could have been plus vn. So maybe let's go with vn so that it will look more like what we want to compare it to. A minus z and then vn. All right, now remember, all this while C is on the left hand side, we still have Cn. Okay. So now don't forget this Cn, we're going to compare this Cn to the original Cn from the question. So now if we look at it carefully, we can safely conclude that A minus Z is sitting nicely exactly where it should be. Okay. Do you agree with that?
Yes, sir.
Okay, good. All right. And then Dn, Dn is sitting exactly where minus 4n is sitting. Okay.
Okay.
So I think it's safe if you look at what's happening on both sides. If you divide both sides by n, right? Some people will say n cancels n, but I think it's better to say divide both sides by n. You would find that n sorry, D is equal to minus 4. Okay, so we'll have that. Therefore, you know that therefore sign, right?
Yes.
Probably one of the most popular symbols in mathematics. So therefore, D equals minus 4. Now that we have that D is equal to minus 4, we can now go to this equation where we have that A minus B equals 52. Remember, that was because of the position, okay? So
Okay.
what are we going to we're going to substitute for D in this equation. So that's going to be now, you know what usually confuses people? Whenever they already see a minus somewhere, you know, they're now wondering, should I still put the minus that came with the original thing? Yes. So because our D is minus 4, it means we still have to leave that minus in front of D and simply put our minus 4 where the D is. So this is how it's going to look. Okay. And
Mhm.
don't forget that all this is equal to 52. So don't forget to write your 52 behind there. So let's see how it looks now. You know that minus minus will give us there's
Plus,
an imaginary
yes.
minus one there. It's going to
Plus.
be one plus, right? A
Yeah.
plus 4 equals 52. So can you tell me
52.
what I'm going to
You bring the 4 over and change the sign to minus 4
that?
to subtract 52.
Yes, to subtract. You're correct. Okay, so another way we could say that is to subtract 4 from both sides. Very, very correct. 52 minus 4. All right. So that's going to give us our A. So somehow we found out what our A and what our B are. 52 minus 4 is 48, right?
Yes, sir.
48. Okay. It says that my battery is low. Okay, so I'm going to read. Let me see if I can quickly switch to my other laptop. Um, okay, 48. Okay, so um, um, so at least we've been able to do the first one, right? Did you understand it?
Yes, I do.
Okay, good. All right, give me a minute. Let me quickly switch to my other laptop so that we can continue. You don't need to leave the meeting. I
Okay.
already have Zoom, so all I just need to do is to transfer the file. To,
Okay, goodness, can you hear me?
Yes, sir.
Okay, that's good. All right. I'm trying to connect my, I don't know why it's not connecting to the system. Okay, well, let's see how we can go ahead. I sent something on the chat. Did you see it?
Yeah.
Like a file.
It's
Okay.
like a picture of what we
Yes, 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 yes. Don't worry. I've seen it. Let me download it. I want to download it to my documents and I'll work with it from there. Okay. Okay. All right. So let me go to pictures now and pick it from there. That was the. So were you writing this thing, or you did not need to write it, right? Since you already have it written down somewhere.
yes.
Okay. All right. So let me image. Okay. So there we go. Okay. So yes, I'm just trying to so that we have the same experience from the other laptop. Okay. All right. So can you see my screen now?
Yes, sir.
Okay. So let's see. Uh, think- okay. Nice one. All right. So you said you understood it, right?
Yes, sir.
Okay. Is there any other one that you didn't understand?
Okay, wait. Let me look for. Hmm, I want to look for the homework.
Okay. You want to share your screen and show me?
I'm still looking for it. I want to look for it first. So I won't.
Okay. All right. All right. Go ahead.
Mm. It's in a textbook. And then Q75. I'm
Okay.
going to share my screen now.
Yes, go ahead. Let me stop sharing.
This
Mhm.
5 and 7.
Okay. Okay, let's see. Um, okay, that first one that you ticked is the one that has those squares, right?
Yes.
Mhm.
Wait, sorry, can I move to a comfortable place real quick?
Okay, yeah, sure,
So
sure.
I
Go ahead.
can.
Mm. Okay, are you good now?
Yes.
Okay. All right. Okay, so the first one, that square has four smaller boxes in it, right?
Yes, sir.
And then the second one has, let's see if I can count it, six.
Yes.
Okay. And then
9.
that last one has eight. Is that eight? 16, sorry.
Yes, 16.
16. Okay. So four, um, so sorry, the one in between has how many again?
The first one has 4. This is 9 and 18.
9 and 16. 4, 9 and
Oh,
16,
yeah,
right?
16. Yeah, 16.
Mm-hmm. Okay, that's nice. Okay, so the first question says what? 4, 9, and 16
Draw the next two term of the pattern.
of the pattern. Okay, all right. So now let's see. Can you establish any trend there? 4, 9, and 16. If I were to just think off the top of my head, right?
Yeah.
4 is 2 squared, isn't it?
Yes.
9 is 3 squared, as in 3 times 3, right?
Yes.
And then 4, the next one is 16, so that is 4 squared. So if
Yeah.
I'm to follow the trend, I'm expecting the next one to be 5 squared,
Yes.
which is 25. And then after that 5 squared one, the next one should be 6 squared, because it looks like they are just increasing by 1, 2,
Yes.
3, 4, 5, and 6. So I think that's so that would take care of the first one. So now, if they're asking you to draw it, is this something you can comfortably draw it, right?
Yeah, I want to set up my tripod so I can hold the phone without me holding it. Sorry,
Oh,
I want
nice, nice, nice. All
you to
right,
start.
that's fine. Okay, go ahead.
I'm trying to bend the. I'll just do a selfie.
Okay, okay, that's fine. That's fine. If you okay, so if you want it to, if you can equally make it so that the mirror reflection can help you with that. I don't know how you exactly want to achieve it, but yeah, if the mirror reflection can help you, that's fine. Okay, let me see. Can I see it like this? Okay, 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 that's fine. I think I can manage it like this. Okay. Draw the next two. Okay.
Let me try put it this side.
Yeah, yeah. I think it's yes. Okay. Okay, yes, yes. This is much better. This is much better. Okay, yes, it's better like this. Okay, draw the next two terms of the pattern. Nice. Okay. All right.
Oh, sorry.
Can it stand? Can it stand like that?
It can, but I have to.
You have to, okay, you have to hold it, right?
I think I have to stretch it a bit up.
Okay. Okay. It's fine now, right? I think
Yeah,
it's okay.
it's
Okay.
fine.
Yes, yes, yes. Full screen mode. Excellent. Okay. All right. So, um, okay, so I was asking, right? The boxes that have what's that? 2, 3, 4 squared. The next one should be 25 and the next one should be 36. You can draw those ones on your own, right?
Yes, sir.
Okay, good. All right. Okay, so the next one says count the number of red squares in each of the first 5 terms and display the results in a table. Okay, so um, they're asking that we display it in a table. Do you have an idea how that table would look?
Um, in each of the 5 things and display.
Okay, so I have a couple of ideas of how the table would look, but I would love to hear your own ideas too. Now, the first the first thing that came to my mind is this. A table, right? How would tables look? Can I annotate? I'm trying to see if I can annotate. Um, hmm. It seems to me like it's only you that can annotate on your screen. But so do you have an idea of how the table would look?
I don't have a. I don't understand the
Let me
question.
allow you to annotate. Hold on, please. Hold on. Um, I think did I allow annotation? Yeah, so you should be able to annotate. Okay, no problem. I can't even find the annotation, allow annotation thing. Okay, so yes. So if you wanted to draw a table, right? You know how um we could do rows and columns, right? So it will look something. Let me see. Sorry, let me quickly share my screen. If you, as it is like this, will you be able to see my screen if I share
Yeah,
my screen without you having to change anything?
yeah, I can manage.
Okay, all right. Let me just quickly share my screen and show you so that I just wanted to show you how I think the table would look. But if you have a different idea, it's fine. The important thing is that you are representing all the information you need to represent on the table, right? So this is what I think the table would look like. So sorry, let me draw my line, take my line. So tables usually look something like this. um, something like this. Okay. Okay. Um, so, and then I'll just have one across like this.
Okay.
Okay. So this is what I'm thinking it will look like. And then you now have 2, 3, 4. Okay. I don't, you know how, what to
Yes.
continue here, right? 5 and
Yeah.
the others.
Yes.
Then, then here, 2 squared is 4. So this is the number of, this side will have the number of squares in each box. 9, 16. Dot, dot. So if this is n, then this is n squared. Okay. So this is what I'm thinking the table would look like. I don't know if you probably have another idea. It's great, but this is what came to my mind when I got that. And you know what that means? If if they had another arrangement, right, where they wanted n cubed, you can equally do n cubed. I'm not saying you
Okay.
should put it to, but I'm just trying to just push your imagination a bit.
Okay.
N cubed will be something like this: 2 raised to power 3, which is 8, 3 raised to power 3. But I'm just thinking this may not really fly because those boxes, if you notice, those boxes, anyway, it might work. Oh, I can't really say because this one contained 9, so it's possible. 27, and then 4 raised to power 3. I think that's 16 times 4 is what? 4 times 6, 24. 4 times 1, 4 plus 2, 6. Okay, so that's 64 years. Okay, so I'll just to push your imagination, but you don't need this part, Sha. You don't need this part. You can leave this
Okay.
part out since that's not part of the original question. Okay, so
Okay.
yeah. Okay, so if you need this, I can send you, when I'm done with this image, I can send it to you. So
Okay.
if you want to still make reference to what we learned in class, it's fine. Okay, so
Okay.
let me stop sharing my screen. We'll go back to your own screen now. Okay, so the next question after that was, it says, describe the sequence of numbers generated by the pattern. Okay, so what kind of sequence will you say this one is? To me, it looks like
Um.
quadratic in a way, right? It's
Yes.
because of the square thingy, the 2 squared, 3 squared, 4 squared. That's what it looks like to me. Oh. I can't call it linear. Certainly can't call it uh, what do you
Exponential.
call that?
Exponential.
Exponential or quadratic and geometric. So I think we can call it's safe to call it
Quadratic.
quadratic. Mm. Okay. Okay. So quadratic would be the answer to that number, that's Roman numeral 3. Then the next one is, how many red squares are there in, is that Tn?
T7.
Oh, T7. Okay, the 7th term. So what do you think will be the answer to that?
Uh, T7. Is it going to be 7 by 7?
7 squared, right?
Yes. That's
Which is
49.
49.
Yeah.
Yes, exactly. Yes, it's going to be 7 squared, which is 49.
Okay.
And of course, I'm sure you can do that last one. Derive the formula for Tn. It's simple. Tn is simply equal to n raised to power 2. There's no, um, I think that's it basically.
Mm. But I was
Yeah.
thinking because my math teacher said anytime you're looking for the seventh term, it should
Mhm.
be instead of T7, it should be T6. That due to the formula, like we always subtract one.
Okay. Hold on. So yes, it's not. It's. I think that happens in um. Ah,
Linear.
wait a minute. So yeah. So let me see. In this case, right, the first box contained four. That even makes it okay. Okay. Let me see. Now that's where it gets a bit tricky. So the first one is 4. That's 2 squared. Mm. N plus 1 squared. The next one is n plus 1 squared. Okay. Okay. I think I understand. I understand what you're saying. So yes, so T7. Um, in this case, you know what I'm thinking about now. The
Mhm.
first term, which should be T1, right? The first term, which should be T1. In this case, um, you can technically say that T1 is the one that has 4 squares, isn't it?
Yes.
So if we're thinking about it now, T1, how would you get 4 squares from T1? The only logical explanation we can give to that is this, that T1 is equal to 1 plus 1 bracket all squared. Okay, so in other words, Tn is equal to n plus 1, then in bracket all squared. So that's the only way we can logically link them together. Okay, so Tn equals n plus 1 all squared. So T7, okay, so if we're going to extend it that way, T7 will be equal to um 7 plus 1 all squared. Okay, so yes, so it's not exactly 7 now, but 7 plus 1.
Okay.
Yes. So now what your teacher said about the n minus 1 thing, right? That one would apply to a sequence like arithmetic sequence and what do you call it? The next one, geometric sequence. But if it's this particular sequence, this particular sequence, we can't grade it as either arithmetic or geometric. So it's unique in its own way. So that's how we'll come up. That's what we'll come up with for it.
Okay.
Yeah. So you now know what's the formula, right? For
Yes.
Tn.
Yes.
Uh-huh. All right. Okay.
Can you just see
Okay.
the number
Okay.
5?
Yes, I can see that one. Yes, I can see it. Okay. Find Tn, the nth term for each of the following quadratic sequences. Okay. 3, 7, 13, 21. Okay. This one looks like like the one we've done now, right?
Uh, yes.
3
Mm.
Between 3 and 7 is 4. Between 7 and 13 is 6. Between 13 and 21 is 8. So 4, 6, 8. So um um okay. So the nth term, the uh Okay, so let me see. Let me step out of this. Tn is going to, so if we're going to arrange it in its quadratic distance, Tn, that would be uh, uh, ax raised to power 2 and plus bx, then plus n thing. Okay. Yes. Okay. So it's quadratic. So the only thing now is that we want to establish what the nth term will be. That's Tn. Okay. So we have 3, 7, 13, and 21. So I'm trying to get what the nth term will be. Okay. Um, okay. Okay. So from what you had in your note, right? What was there was a general formula that you that
Wait, let me check if
had.
it's in the textbook.
Okay. So let's take a look at that general formula, because it's from that general formula that the nth term will form in this
Mm,
case.
wait,
Okay.
this one.
Hmm. Okay, let me see. Okay, so the general term for any arithmetic. No, okay, this one is arithmetic. It's quadratic that
Yeah. The general term
mm,
for quadratic.
yes, quadratic.
Okay.
Quadratic.
Oh, yeah.
Okay, okay. Um, let me see. Okay, okay. That's b ax squared uh, ax squared plus b plus 2b plus a plus b plus c. bn. Okay, I'm just looking. That's middle term that's there, right? That middle term that's there. Okay,
Yes.
okay,
And
yes,
this is the
yes. Okay,
term.
don't worry. Yes. Okay. Don't worry. Don't worry. That first one was okay. Ax squared plus bn plus c.
Yeah.
Okay. Okay. So it says the second difference is the non-zero constant. Is that 2a or 2b?
Mm,
Yes, that last line there.
oh, is 2A.
2a. Okay. Okay. Okay, that's 2a. That's 2 times the first term, right?
I feel like it's going to be 2A equals to the answer. Wait, let me show you.
Okay.
For what we did today for the
Mm,
quadratic,
okay.
this starting from here to
Okay.
yeah.
Mm, okay. 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 So 2a is the difference between the first is the second the constant second difference. Okay. Mm, 4 squared. Okay. All right. Tn is 4n squared. Okay. Plus bn plus c. Okay. Okay. 4n squared plus bn plus c. Okay. All right. So if we apply this same idea, right, to the one that we have there. Um, okay. Okay. So at this point we came up with two um, simultaneous equations, and that would help us to find what B and C are. Okay. Okay. I think I see what's going on at that point. Okay. Okay. I see what's going on at that point. 4n squared plus bn plus c. Okay. All right. Okay. Okay. All right. Okay, let's go back to the question so that we can apply that to the to that question and see if we can what our get what the terms are. Um, but did you appreciate the fact why there needs to be a simultaneous equation?
I think to find the B and C, you have to do
Yeah, yeah, to find the B and C because that B and C is constant for the different terms, so they are the same. Okay. All right, let's go back to the question you wanted us to take care of. Um, let's see. Okay. Okay, is this number 8 that you marked?
Oh, number 2.
Um, I can't see it. I'm
Oh
not sure I
yeah.
can see it.
Wait.
Okay. All right. Okay, yes. Okay. Okay, so it says find t and the nth term for each of the following quadratic sequences. Okay. Okay, so let's see that first one, right? 3, 7, 13, 21. Okay, so what would be the second common difference for this one? That's steady. 3 plus 4, 7 plus 6. So it seems to be 2.
2, yes.
Yes, 2. Okay. So our A, that means our A is 1, isn't it?
Yes.
Our A is 1. So if we follow that, um, um, if we follow that idea, then let me see if I can build that up on this side. Okay. You can see my screen, right?
Oh, let me check now.
Okay.
Yes, I can.
Okay. Um, okay, so I'm just modifying this. I think this too should be modified. So a n squared plus, okay, plus bn plus c. This is the general formula, right? An squared plus bn plus c. So if we
Yeah.
work with this, I think we can establish it. So we've gotten from that particular one that we're doing now that um, A is 1. So that's 1 n
It's
squared. That's
good.
as good as n squared, yes. Okay. And then we have our what? Our B. Our B is still there. And then our C is still there. Okay. All right. So um um which we can use any of the terms, right? So that we can get that simultaneous equation. The first term
Yeah.
is
Mm.
the first term is 3,
Yes.
isn't it? Okay, so let's use the first term and the second term. So the first term is 3. So T1 is equal to 1 squared which is 1, plus B times 1, which is B, plus C. Okay. And so that's is equal to 3. So I think from this we can conclude that B, if we take 1 to the other side, right? B plus C will be equal to 3 minus 1, which is 2. Do you agree with that?
Yes.
Okay. So this is equation 1. So let's see if we can do the same thing for the next term. The
7.
next term is 7, isn't it?
Yes, sir.
Okay, that's T2. So T2 will be equal to 2 squared, which is 4, plus 2B, and then plus C. Okay. And all that is equal to 7. Okay. All right. So here we go. 4 will go to the other side. So you're left with 2B plus C. Okay. 2B plus C is equal to 7 minus 4. That's 3. Okay.
Sorry, how
All right.
did you get the 4?
Okay, the 4. Here, n
Oh, okay,
squared,
okay.
the,
The
yeah,
answer for the year. Okay.
you get the general formula that I got for the Tn. So
Okay.
since n is 2, you get, so 2
Yeah,
squared is 4. That's
reciprocal.
how,
Yes, yes.
yeah, exactly. So 2b plus c equals 3. So this will be my equation 2. So are you good with simultaneous equations?
Yes.
Okay, all right. So if we were to solve it, there are different methods for simultaneous equation. If you want to use what they call that thing, substitution method, that's fine. If you want to use elimination method, that's fine. So which method do you usually prefer?
Elimination.
Elimination. Okay, so let's do elimination method. So you can do equation 2 minus equation 1. So that would be 2b plus c equals 3. That's equation 2. And then minus equation 1, which is b plus c equals 2. Okay, so let's run this and see how it looks. So now, of course, you know there are different ways we can do this, but let's try and eliminate c. So if we're eliminating c, we'll have that 2b minus b is what? B, right?
Yes.
And then c minus c is 0, so that eliminates c. And 3 minus 2 is 1. So
Yeah.
that means therefore b is 1. So we have concluded what b is, but now let us go and find c. If b is 1, then we can substitute in either this one or this one to get c. So we'll have that, therefore, 1. Okay, so let's substitute in the simpler one. That's equation 1. 1 plus c equals 2, right?
Yeah.
Okay. And that means, therefore, c will be equal to what? 2 minus 1, isn't it?
Yes, and that be one.
2 minus 1, which is 1. Okay. So that means b is 1 and c is 1. So I think that would help us to establish our Tn as what? Our Tn. You remember our Tn, this one.
Yes.
So now we know or maybe not even this one, sir. Is this one, this second one is the one that looks closer to, because this second one, we now know A and we now know B and C. So I think we can now safely say that therefore Tn is equal to n squared
Minus
plus bn plus one plus n, sorry, since we already know that b is 1, and
yeah.
then plus c, which is also 1. So yes. Okay. So would you like us to go over it again?
No, it's fine. Now I understand how to solve it.
Okay, okay. All right. Okay. Would you be able to do the other ones yourself?
Yes, I can.
Okay, that's nice. Okay, that's fine. All right. I think there was one more you marked. Would you like us to take a look at it?
Okay.
Okay. Let me unshare.
That's
Okay.
7.
Okay, 7. That one that has that pattern, right?
Yes.
Okay, so that one looks very similar to the one of the square boxes. It
Yeah.
says dot should represent the first 3 star numbers. That first one has 1, 2, 3. How many there? 1, 2, that's 3, 4, 5, 6, 7, 8. So that first one has 8. That second one seems to have, let's see. Yeah, that first one has 8. So let's count that
8.
second one.
1, 2,
Uh-huh.
3,
Yeah,
21.
21. Okay. So 8, 21. Let's count the third one.
Thirty-nine. Wait, let me count it again.
Okay. Yeah. First one is 8.
It's 40. And then,
Okay, it's 40, eh?
yeah, that's 21.
Okay, 8, 21, and 40. Hmm.
Wait, 1, 2. Yeah, it's 21.
Okay. 8, 21, and 40.
Yes.
Does it look like a quadratic thing?
Mm,
It looks like quadratic. So let's establish it. 8, 21. What's the difference between 8 and 21? That's 13.
yes.
What's the difference between 21 and 40?
19.
That 19. 19, right?
Yes.
13, 19. Hmm. Okay. 8. Okay. You know what? It looks to me like we can't even use only 3 terms and establish if this thing is quadratic or not. I think we have to find another way to figure it out. The first one contains 8 dots. The second one contains 21. The third one contains 40, right?
Yes.
Okay, so let's do some thinking here. 8, 21, and 40. Okay, so 8 is the first term, 21 is the second term, 40 is the third term. Okay. Hmm. Between 8 and 21, we have 13. Yeah. Between 21 and 40, you have 19, right? Plus 2 plus 1 is 3, plus 1, 4. Okay. Hmm. This is a tough one now. Okay. Anyway, I want to believe you counted right. Right. 8, 1, 2, 3. Okay.
Well, I think he's
Hmm.
trying to ask us what are the numbers instead of the sequence.
Yes, but at a point it will ask you what's the nth term.
Yeah.
So I think it's something that we'll need to figure out. Okay. So uh this guy looks okay. 8, 13, 19. Hmm.
Oh, I think you divide it or something.
Okay. Divide
Yeah, because it says find the 58th star number.
the 50th term or the 50th
Star number.
number. Hmm.
8, 21, 40.
Hmm. Uh, okay. Wow. Okay. Hmm. Did they give any hints on what this might be?
Can I check the back if I can see you guys in?
Okay, all right. Go ahead. Go ahead.
Nice. 8.4.
Because this one didn't even give no hint on whether it's quadratic or linear or what.
For that's question 7. It says one is 8.21, and then this is the answer. This one.
Uh, hold on, let me unshare my screen.
Mm.
Okay, okay. So I think that one was just for us to count now, right?
Yes, and then the second one.
The second one was what?
uh,
What was the question? Second one.
Find the
It's
TN.
the first three terms.
The second one was find a formula for TN.
Sorry, sorry, I'm looking at the wrong question. Okay, find the formula for Tn, the nth star number. Okay. Ah, so how would they have arrived at this thing?
Let me check.
Okay, I think okay, you know what? Let's look at that pattern, right? Let's look at the pattern there. If you look at the dots, the first one has 3 dots above and 3 dots beneath,
Yeah.
and then 2 at the extreme end. Two, no, look at the first one, the first star. The first star, yes. If you look at it very well, you see 3 on top, 3 below, and
Yeah.
2 on the extreme sides, one on the left, one on the right. So
Okay.
if let's look at the next one. The next one has, instead of three dots, 3 above, 3 below in triangular formation, you have 1, 2, 3, 4, 5, 6. So you have 6 above, 6 below. Okay.
Six.
Now
Six.
we now have Yeah, we now have
2 in the middle.
1, 2. Oh my, this question is funny. We now have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Ah, this question is pretty tasky. Oh, okay. Yeah, I see something here. I think I can see something here. So, so, so there are triangles on 4 sides. There's one on the north, one on the south, one on the east, and one on the west. That's what I see. Oh. That's what
Yeah,
I
but like,
see.
I was thinking
So,
if it's like this, that
yeah,
means the
there's a square,
dot
like
will be,
there's a square pattern inside, right?
oh yes, like this.
Can you see that square pattern inside? Yeah, exactly. And so draw the square pattern for the first one. Exactly. Nice. And that will help us to isolate it. So we now have 4 dots around. Okay, good. Yes. Nice one. Okay, so let's look at that second one. That second one has how many dots in the square pattern? The first one has 4. Second one has 9,
9.
isn't it?
Yes.
Uh-huh. And the next one has 16, right?
Exactly. Yes.
Okay. So now let's now look at how the other ones are formed around it. We have the first one has only one dot around. The next one has 3 dots around. The next one should have, is that 5 or 6?
Which one?
That's the third one. The third one has how many dots in the triangle around it? One,
Um,
two,
uh,
three, four, five.
oh, 16.
No, okay, 16 inside. But how about let's look at the triangle on the left and on
Oh,
the right
6.
here at the bottom. It's 6.
6.
Okay. So 1, 3, and 6. Do you think there's any relationship there?
Mm,
One,
yeah.
three, 6.
Is it not linear? Oh, I don't.
There's
There's 3
it's not right.
differences. But no.
Mm-hmm.
But I was thinking 1, 3, because the difference between 1, 3 should be 2, and then 3 and 6.
Yes. Ah, okay. Anyway, at least we were able to identify something, right? At
Mm.
least.
I will see if
Um,
I'll ask her to do
one.
the correction for the last questions to see how
Okay,
she will
okay,
solve it
okay,
tomorrow
okay.
on Thursday.
The, yes. Oh, when do you have the next class?
Thursday.
On Thursday. Okay. As in school too. That's when you people have maths, right?
Yes. We have
Okay.
maths
All right.
Monday, Tuesday, and Thursday.
Okay. That's good. Okay. Not a problem. Okay. All right. No problem. I'm sure we'll be able to learn 1 or 2 things from this one.
All right.
Okay. So that's it, right?
Yes.
Okay. All right. Okay, so I'll see if I can actually get the e-copy of this book. It will really be nice. At least it will help us with um, so it won't be inconveniencing for you. But anyway, if we've worked something out, if I can't find it, then we might just work with this. Can you send me the name of this textbook? Let me see if I
Okay.
can find its e-copy online.
Okay.
If I can see the name. Um, Okay, certificate maths. Um, um, I can't really see everything. I think you may need to move it.
Okay.
Okay, yeah, but yeah, that's better. Okay, learning, living certificate maths, higher level. Okay, active, second edition. Okay, let me see. Can I do a screenshot? Let me see if I can do a screenshot. Okay. All right. Have I taken it? Active. Okay, living certificate, higher level, paper one. Okay. I think I've done a screenshot, so I'll be able to find it. Active maths. But if I don't find it, then we might just have to still stick with this.
I will try to check if uh,
Okay.
if you can see online, and
Okay.
the link should be here.
Okay. Okay. So so I think this living certificate is like uh would I say they allow they expose you guys to the content for the last class in high school, right?
Oh yes.
Okay, okay, okay,
Is it I don't understand what you mean by
okay. What I mean is now, okay, so it's I mean I'm just looking at the name of the book, Living Certificate. So I'm thinking
oh,
it's
the name of the
full.
book is active, but like living certification and certificate is for like people that are doing like I am math higher level is people that are doing like hard math,
Okay, okay,
like further
okay.
math.
Yeah. Okay. Okay, that's nice. That's nice. Okay. Okay. All right. You can still also look out for it. I would also look on my own side. If you can find it, that would be great. It means we would
Yeah, I'll
have
look for the
to be
link.
mm,
Yeah.
okay. Okay. For the link, right?
The
Okay, yeah.
website, yeah, the website.
All right. The website too. Okay, that's fine. All right then. So I think would meet again on Thursday then.
Okay.
Okay. Okay. I hope you enjoyed today's class.
Yes, I did.
Okay. All right. Thank you too. I enjoyed it too. All right. So see you on Thursday.
Okay, sir.
Enjoy the rest of your evening.
Thank you, sir. I need to.